Hello, and welcome to yet another riveting video over Section 5. And this is from Unit 4, Section 5. This is Triangle Congruence. We're talking about SAS. And SAS is an acronym, or as I like to call a TLA. Do you guys know what a TLA is? It's a 3-letter acronym. But SAS stands for side, angle, side. Okay? And what we want to do today is we want to determine the isometric transformations that would map one triangle onto another, given two corresponding sides that include an angle or congruent. We want to identify the sides and angle that can be used to prove triangle congruency using side, angle, side. We want to complete the steps to prove triangles are congruent using SAS, side, angle, side. So let's talk about congruent triangles. Okay? Congruent triangles are triangles that have their corresponding sides and angles are congruent. Okay? So let me just come up with an example here. Okay? Let's just say I have a triangle like this. All right? And another triangle just like that. Okay? I'm going to call this triangle A, B, C. And I'm going to call this triangle D, E, F. Okay, now what I want to say, if these two triangles are congruent, then I would say that angle A is congruent to angle D. Okay, angle B is congruent to angle E, and that angle C is congruent to angle F. Okay? Now the other thing that I can come in and say is that segment AB is congruent to segment DE. All right? If I know that they are congruent, then I would say that segment BC is congruent to segment EF. Okay? And then I would also come in and say that segment AC is congruent to segment DF. Okay? And so here's what we can say about all this. All right? I would say that angle A is congruent to angle D. Okay? I would say that angle B is congruent to angle E. And I would say that angle C is congruent to angle F. Okay? So that's for the angles. Okay? So the corresponding angles are congruent. We could also say that the corresponding sides are congruent. So for the sides, okay, I would do this. I would say segment AB is congruent to segment DE. Okay? I would say segment BC is congruent to segment EF. Okay? And then I would say that segment AC is congruent to segment DF. All right? So all my corresponding angles are congruent. All my corresponding sides are congruent. All right? And then we want to talk about how to name this. Okay? Now what I would do in this situation, naming is the important thing. Okay? And it helps me figure out what angles are congruent to what other angles. So what I would do is I would say this, that triangle ABC, okay, is congruent to triangle DEF. Okay? Now here's the reason why. Okay? Triangle A, or angle A, corresponds with angle D. Angle E corresponds with angle B. And then angle C corresponds with angle F. All right, and that's how I name it. Now you can name it another way. Okay, you can name it, say, triangle BCA. Okay, if I name that triangle BCA, if I were to name the other one, okay, and making sure that they're congruent, I would name it as EFD, triangle EFD. Okay, I could even say this. I could say triangle, CAB, triangle CAB, is equal to triangle FDE. All right. So it doesn't matter how you name it, as long as each of these angles and vertices on that triangle are in the same order. Okay. So now let's quickly talk about what side angle side congruence means. Okay. And we'll do an activity about this in class at some point. But what we would say, okay, and the definition says, if two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent, okay? So what I have is this, okay? The congruent statements, and I'm going to write these down, the congruence statements are as such. Okay, I would say in this triangle over here, I've got ED, okay, ED is congruent to AB. Okay, so I know that this segment is congruent to this segment. The next thing I would say is that angle D is congruent to angle A, all right, which is seen here just by that picture. The other thing I could say is that segment DF is congruent to segment AC, okay? So I have a side length, I have an angle measure, and I have a side length. Now, when I look at this triangle, I'm going to say this. I'm going to go, okay, I have a side length, I have an angle measure, and I have a side length. All right? I have a side length, an angle measure, and a side length. So I have two sides, two pairs of sides that are congruent, and we have an included angle. So if that's the case, then I would say this. Okay? Triangle, and I'm just going to go EDF, EDF, is congruent to, okay, so E corresponds with B, so triangle B, and then A and C, okay? So, and you can name this a number of ways, but I named it as such going around the triangle, EDF, so BAC, those are the parts that correspond, okay? And the reason why I can say this, these are congruent by side angle side congruence theorem. And that's what you need to say, all right? So that's the idea. It's all about you looking at a picture and saying, okay, I have a side, I have an included angle and another side, and on this picture I have a side, an included angle, and another side that are congruent. So I know that the triangles are congruent. And if the triangles are congruent, then all the other angles and all the other sides would also be congruent. This is really fun. I'm having a good time right now. I want you to know that. Okay, so let's take a look at the next page, and it says, can we use the side angle side congruence theorem to prove that the two triangles are in fact congruent? So over here, okay, here's what I've got. I've got that QR, or RQ, okay, is congruent to FE, congruent to FE. Okay, I also have that angle Q is congruent to angle E. And then I've got that angle, or I'm sorry, segment PQ, okay, is congruent to segment EG. All right, so I have a side, I have an angle measure, and I have a side. Okay, and if I look at this, I've got a side length, an angle measure, and a side. I have a side length, an angle measure, and then another side. Okay, so what I would say is that triangle PQR is congruent to triangle GEF, by using the side angle side congruence theorem. Okay? So if you're given that scenario, it'll work. Okay? Now let's look at the next one. The next one, not so much. Okay? Now what you have, even though you have these statements of, US is congruent to VW, okay? You've got ST is congruent to VT, okay? And then you have angle STU is congruent to angle VTW, okay? But here's the problem. As I go around this triangle, as I go around, I see I have a side length, and an angle measure. Okay? And as I look at this picture, as I go around the triangle, I have a side length, I have a side length, and an angle measure. I have a side length, I have a side length, and I have an angle measure. So I can't conclude that these are congruent. Now, they very well might be, but I don't know anything about the included angle, S and V. Okay? So the question is angle S congruent to angle V? And I don't know. Okay? We're not given that information. So because it doesn't, you have to have the included side or included angle in between these two sides in order for you to say that these are congruent. So this, we can't tell. Okay, we can't tell if they are congruent. Okay, they might be, but we don't know. All right, so it has to have the included angle. Rule of thumb, if you spell a bad word, SSA, it ain't going to be congruent. That's funny, right? We're having a good time? Yeah. Okay. So you have to be able, and hopefully you see the difference between this scenario and this scenario. Okay? That's the idea. All right, so let's do a proof. Okay? So what I know, okay, is that EG and DF bisect each other at M. Okay? So EG and DF bisect each other at M. So that means that these segments are congruent and these segments are congruent. Okay, so let's write a two-column proof here. Okay, here's my statements. And then our reasons. Okay. So what I've got, okay, is that if EG and DF bisect each other at M, okay, I've got this. I'm going to say that EG and DF bisect each other at point M. Okay, that's given to you. It's like a Christmas gift, only better. Okay, part two, okay, I can then say that EM is congruent then to MG. Okay? And the reason I can say that is because that's the definition of a bisector. Okay? The third statement I can make is that DM, okay, DM is congruent to MF. Okay? The reason I can say that again is the same thing. It's the definition of a bisector. Okay? All right. Now, the other thing I can say is that this angle here, EMD, is congruent to the other angle, GMF. Okay? So I'm going to say that in step 4. Okay? I'm going to say that angle, what was it, EMD is congruent to angle GMF. Okay, and the reason I can say that is because those are vertical angles. Okay, now here's what you have to realize. Okay, I have a side length, I have an angle measure, and I have a side length. That angle is included between those two sides. Here I've got a side length, an angle measure, and another side length. And that angle measure is included between those two congruent sides. So I can then draw the conclusion, okay, and make my proof statement saying that they're congruent, that, so I'm going to say that in step 5, that triangle DEM is congruent to triangle FGM, and the reason why is because of side angle side. Okay? I don't know anything about whether ED is congruent to FG. Yeah, I don't have that. I don't know what angle D is. I don't know what angle F is. I don't know what angle E is or G. Okay, so I can't just, I'm not just given all that information and said that they're congruent, but I can prove that these two triangles are the same size and same shape based off of side angle side. okay? Okay, I'm going to stop the video here. I will try and do this other one in class at some other point, but that's the idea between, side angle side. So I hope you enjoyed the video. We'll talk to you later. See ya. Bye.